Today we're going to continue our work with interpreting graphs, and we're going to do a few more examples of how to interpret graphs when they ask for x and y intercepts, positive and negative, and increasing and decreasing. First of all, number one, we're going to talk about right whale populations, and we're going to be comparing the generation since 2007 with the population. Now what this means is, it doesn't mean years since 2007. For example, this 4 right here does not mean that it's going to be talking about 2011. It's talking about generations. So generations are like generations of new offspring. For example, you are the generation after your parents, who is a different generation from your grandparents, who is a different generation from their parents. So each new line of offspring is a generation. Now, if you'll look, right whales, the population is going down each generation, so just keep that in mind. Now the first question they want to know, is this linear or is this non-linear? So is it a straight line or not? And this is a straight line, so this is linear. Then they want to know the x-intercept. So according to this up here, the x-intercept is where the graph crosses the x-axis. Now the x-axis is this dude right here, and my graph only touches the x-axis in one place, this guy right here. So we just need to write the ordered pair for that guy. Now the x value at that point is 10, comma, the y value at that point is 0, so the x-intercept is 10, comma 0. And the y-intercept is where my graph crosses the y-axis. So here's my y-axis, and my graph only touches that y-axis right here. Now the x value, because it's x comma y, of that ordered pair is 0. And the y value is just a little bit different than what we've been working with in the past. It doesn't look like it's exactly at the intersection. So when it's not exactly where we want it to be, we have to approximate, which is totally okay, because we're just kind of guessing about what the graph is talking about anyways. However, to show that we are approximating, we need to use the approximation symbols, which are the it looks like a squiggly equal sign, and that means it's approximately. So the y-intercept is at approximately, and it looks like that's about 240, but we don't know for sure, so I'm just going to say about 240. So I have my x-intercept and my y-intercept. I just need to interpret those 2 points. Now, I do not need to interpret what's happening in the middle. I just need to start by talking about this point and end by talking about this point, because we go from left to right. So if we start by talking about this intercept, that's saying that at 0, it was about 240. So what does that mean in like real people words? So 0 on the x-axis was representing generations since 2007. So to me, that means that 0 generations after 2007, well, if it was 0 generations after 2007, that means we're talking about 2007. So in 2007, there were about 240 right whales. Again, if you need to pause the video to write this down, you are welcome to do so. Now we can talk about the x-intercept. The x-intercept shows that the x-axis is 10, so 10 generations since 2007. That is where the population was 0. So for me, that means that after 10 generations, there will be no more right whales. Next, I need to talk about where my graph is positive and where it is negative. Remember, positive and negative are all about how it is in relation to the x-axis. So when my graph is above the x-axis, it's positive, and when it's below the x-axis, it's negative. So it is, when I start looking at the graph, it starts above the x-axis, and as far as we can see, the whole time that we have the graph, it stays above the x-axis. So we talk about it in terms of x, so it starts here. So from x equals 0 to, and it goes all the way to where it intersects, and that is x equals 10. Now negative is where my graph is below the x-axis. And if you'll notice, any time that they gave us the graph, it never goes below the x-axis. Yes, the graph continues, but we don't actually see that. So from what we see, the graph is not negative. Increasing and decreasing have to deal with where the graph goes up or where the graph goes down as we read from left to right. So if I'm following the graph with my pencil as I'm reading it from left to right, and if I trace the whole thing, you'll notice that the whole time my pencil is going down. That means the entire time my graph is decreasing. There is no place where my graph is increasing. So to show that it's not increasing, we can put the 0 with the line through it. But it decreases starting here, so from x equals 0 to ending here, x equals 10. So from x equals 0 to x equals 10. Now number two, we're talking about a swimming blue dolphin, and we're comparing the time since entering the water in seconds versus the height in meters. Now, pay very close attention to this graph because the x-axis is not on the bottom like it has been in the past. Here the x-axis is right here. So it's kind of, they shifted it so we could see more of the graph. So first question, is this linear or nonlinear? This is not a straight line the whole time, so it is nonlinear. The x-intercepts are where the graph crosses the x-axis. So here's my x-axis that I'm highlighting. And let's see how many times my graph crosses that x-axis. It starts by touching the x-axis right here, so that's 1. It touches it here, that's 2. And it touches it here, that's 3. So my graph actually has 3 x-intercepts, and that's okay. Your graph can have an infinite amount of x-intercepts, or it could have no x-intercepts. Sometimes that happens. So don't feel worried if you have more than one x-intercept. So let's write these ordered pairs. This first ordered pair is right at the origin, so that is 0, 0. This ordered pair right here, the x value isn't quite right at 5, but it's close, so we're going to have to approximate. I'm going to say that's about 5, and the y value is at 0. And then my third one looks like it's halfway between 6 and 7, so we're going to have to approximate that as well. We're going to say about 6.5, comma 0. So I've got my 3 x-intercepts. Now my y-intercepts are where my graph crosses the y-axis, so this guy right here. Notice it only touches the y-axis once, so there's only one y-intercept, which is at 0, 0. Next, they want us to interpret the intercepts. Now remember, I don't care about what's happening in between the x-intercepts. I just want to know, or all of the intercepts, I just want to know what's happening at them. So like, I completely understand that if I were to read this graph, the dolphin's under the water and he's swimming down here and then he comes up and he jumps and he comes back down. That's awesome, but that's not what I want you to write. I want you to describe what's happening just at the intercepts. So if I start with my first intercept, that is at time 0, and that is when the height is 0. So at that very point, the dolphin starts at the surface of the water, because this is like where the water is. The dolphin starts at the surface of the water. Now the next intercept is this guy right here at about 5 seconds. So at about 5 seconds, we know that the dolphin is at the surface of the water again. So that's what we need to say. So after about 5 seconds, the dolphin returned to the surface. And our third intercept right here, again, the dolphin is re-entering the water, because we know that he jumped out here and came back in. So just at that point, at about 6.5 seconds, he re-entered the water. Next, we want to talk about where my graph is positive and where it is negative. Now, this one is going to be a little bit trickier than the past ones because this one, the x-axis, is kind of in the middle of our graph. So my graph is positive when it is above this highlighted line of the x-axis. Well, it is only above the x-axis right here in blue. So it starts being above the x-axis right there and stops being above the x-axis right there. So we talk about it being positive in terms of x. So it is positive from x equals, now this right here was about 5 seconds, to it stops being positive right here, which we said was about 6.5. So my graph is positive from x is about 5 to about 6.5. Now my graph is negative when it is below the x-axis. So here the x-axis is in green. It's negative when it's below. So it starts being negative there, and here it's still below, and here it's going up, but it's still below the x-axis. And then even over here a little bit, it's below the x-axis. So we've got quite a bit of negative graph here. So we're going to say that it starts being negative at x equals 0, right when we started. And then it's still below, still below, still below, still below. It stops being negative when it crosses that x-axis at that intercept. So it stops being negative at about 5 seconds. And it's also negative right here. So it starts being negative again at about 6.5. And it stops being negative when our graph ends at 7. So notice how my graph is negative in 2 different sections, and that's okay. Sometimes your graph will be negative in multiple sections, sometimes it'll be positive in multiple sections. It all just depends on what you're given. Now we want to talk about where my graph is increasing and where it's decreasing. So remember, increasing is when you're tracing your graph and your pencil is going up. Decreasing is where you're tracing your graph and your pencil's going down. So if I start tracing my graph from left to right, my pencil is going down, which means I'm decreasing. Then it kind of changes directions, but I'm still going down. So here to here, I'm going down. This is all decreasing. But once I get to this point, I change directions completely and I'm going up. So from here to here would be increasing as my pencil is going up from left to right. And then again it changed directions again and now I'm going down. So where I have in green I'm increasing and where I have in red I'm decreasing. Increasing is up, decreasing is down. So I am increasing from, in terms of x, I start increasing right here, which is, I've got a scale of 1 here, x equals 3, to x equals, and I stop right here where it changes to red, x equals 6. Now I'm decreasing, I start decreasing at x equals 0, and I stop decreasing where it changes to green, so to x equals 3. Then I start again where it changes from green to red, so and x equals 6, and I stop at the end of the graph, so x equals 7. Next, we are going to talk about water level, and we're going to be comparing the time in seconds to the water level in centimeters. So first of all, is this linear or nonlinear? This is not a straight line, so this would be nonlinear. Then I want the x-intercept, so that's where my graph crosses the x-axis. Well, according to what they gave us, my graph never touches the x-axis. So all that means is I don't have an x-intercept. I just got to put the 0 with a slash through it, and that's okay, that happens. Now I want to talk about my y-intercept. My y-intercept is where my graph crosses the y-axis, and that happens at one point right here. and that is a little bit above 42, so I'm just going to say that's about 42. So ordered pairs, the x comma y, my x value right here is 0, and my y value we said was about 42. Now, when interpreting the intercepts, I only have one intercept. That's okay. I'm only going to talk about what's happening at this point. So at that point, time is 0, and the water level is about 42 centimeters. However, I don't want to say, at time 0, the water level is about 42 centimeters. No, we just need to say the water level started at about 42 centimeters. Or you could say, initially, that's a great word to describe something in the beginning. Initially, the water level was 42 centimeters. You just need to describe how it starts, and you're fine. Now, positive is where my graph is above the x-axis. Notice my graph never goes below the x-axis, so it's positive the whole time. So again, in terms of x values, we're going to say from x equals 0, because that's where x starts, and then we go all the way to x equals 240. It never stops being positive. Negative is where my graph goes below the x-axis. Well, it never goes below the x-axis, so it's never negative. Increasing is where when I trace my graph from left to right, it goes up. So if I'm tracing my graph here from left to right, going down, going down, going down, going down. I'm going down less, but I'm still going down. So I am decreasing this entire graph. I'm never increasing. So I can put that I'm never increasing there. And I'm decreasing from x equals 0 to x equals, and I stop when the graph stops, 240. Now, I understand, guys, that this can be a little bit confusing. Take it a little bit at a time. Take it slow. Make sure you come in and get help. Check it with the answer key. This is really important to be able to understand the difference between positive and negative, increasing and decreasing, interpreting the intercepts. It can all be very confusing, so you need to make sure you're coming and getting help. Now, we're just going to finish off with a little bit of fill in the blank here. Number 4, actually what I would like you to do, I would like you to pause the video, and I would like you to try and fill out these last 5 questions with the answers. Then come back and we can talk about them together. All right, number 4, hopefully you said to add fractions, you must have a common denominator. Common denominators are very important to add fractions. For number 5, for terms to be like terms, they must have the exact same variable raised to the exact same exponent. So for terms to be like terms, they must have the exact same variables raised to the exact same exponent. Number 6, the domain is the set of the x-coordinates, and remember the range was the set of the y-coordinates. Number 7, the point 0, 0 is called the origin. And then number 8, in the expression 3x to the 4th, the number 3 is called the coefficient. I-C, goodness. I-E-N-T, coefficient. All right, that does it for this lesson. If you guys have any questions, let me know.